Welcome to another video from explainingcomputers.com. This time I'm experimenting shooting YouTube video on a Raspberry Pi camera. And this follows my experiments building a CinePi, a Raspberry Pi cinema camera in a recent video, although here I'm going to be testing out a broader range of setups. In case you're wondering, this shot is being recorded from a Raspberry Pi camera, specifically a Raspberry Pi high quality camera with a 16mm lens, and every time we have Raspberry Pi footage in this video, there'll be a graphic top left indicating it is Raspberry Pi footage and also indicating the lens being used. This footage is being shot green screen at all the introductions to my video, so let's just take away the background like that and put it back again, and as you can see, chroma key is working pretty well. Now clearly, a Raspberry Pi high quality camera is very different to the camera I normally use to shoot my YouTube content, which at the moment is normally a Panasonic HC-X2. And I'm sure you'd like to see a comparison, so let's do that. Here I am on the Raspberry Pi high quality camera talking to you, but with the Panasonic next to me, and clearly there is a big quality difference. This said, the Panasonic is a lot more expensive. Specifically, a Raspberry Pi high quality camera and a lens cost at least 25 times less than the Panasonic. And in that context, I think the quality we're getting from the Raspberry Pi is pretty reasonable, and there are lots of things we can experiment with. Right. Here we have the standalone CinePi or Raspberry Pi cinema camera that I put together in a recent video. However, here we're going to be starting with this setup, which is what I used to record the opening shot to this video as we were just looking at. And what we have here is a Raspberry Pi high quality camera, and I think I'm going to start calling it just the Pi Cam because Raspberry Pi high quality camera is far too long to keep saying. And right now this is connected to a 2GB Raspberry Pi 4. It was connected to an 8GB Raspberry Pi 4 and a touchscreen for the CinePi setup I just showed you, and as I need to return to that later in the video, I thought I won't try removing the screen and putting it back, that's a precarious operation. I thought I'd just switch Pis. And a 2GB Pi 4 is fine for what we're doing here, but you could also use a Pi 5 if you wanted to. And everything is held together via this sort of plastic bracket thing I made in the last video, and in turn everything is bolted to this small rig cheese plate, which basically allows us to hold everything together and also allows us to attach a tripod mount. Right now on the front of the Pi Cam is the standard 16mm C-mount lens that's often sold for use with the Pi Cam. This is a telephoto lens used with the camera. However, we're also going to be testing out this lens. This is a wide-angle lens, a 6mm CS mount lens, and we'll just see what the difference is. And also we're going to be testing out this lens. I found this on eBay. This is a low-cost 6 to 60mm C-mount zoom lens. It might be rubbish, it might be fantastic. We will find out a bit later in the video. Anyway, initially what we're going to be doing is directing the camera's output to the Raspberry Pi's HDMI connector, and we'll then be able to record this using either a standalone HDMI recorder, which is how I record most Explaining Computers videos, or we could record using this. This is a USB to HDMI adapter. And so what this will effectively do is to turn the camera into a webcam, which we could then record using something like OBS Studio on another computer. Oh, and of course we could also record the output from the camera directly on the Raspberry Pi, and we'll be trying that as well. Anyway, let's now boot this up and go across to the desktop. Here we are running the latest version of Raspberry Pi OS, and via the magic of filmmaking, our camera rig is now mounted on a tripod and looking across the room at something vaguely interesting. So, shall we take a look at what it's looking at? Why not? And to do so, we will launch the terminal like that, and we will do an rpicam hello command like that. This will give us a 5-second preview of what the camera is seeing. I haven't focused it yet, I can do that a bit later. It'll disappear in a second, only a 5-second preview. So let's improve on that. Let's do a width 1920 and a height 1080, and that should sort out the aspect ratio. It has, that is now a 16:9 preview, but it's still not the right size. So let's bring it back again and do a -F for full screen. Keep adding our flags, and there we are. We've now got a full screen preview, but it'll only last 5 seconds again. There it goes. So we want it to last a little bit longer if we want to record this output. So we're going to do a -T for timeout, and we can specify here any length of time we want for the preview, but if we enter a time of 0, the preview will last until the end of time, or at least until the sun explodes, something like that. So let's press enter again, and there we are. We've now got a continuous preview, which means I can leap in and adjust the focus. There we are. It's not very exciting, is it? Some boxes across the room. Just seemed a good thing to point the camera at. In focus, it's about there, isn't it? We've got a little bit of a... I think it's about there. That I think will do. And we've only got 2 problems now. If we wanted to record this output via some means of HDMI recording. And the 2 problems are that we've got a pointer on the screen and we've got a taskbar at the top of the screen. And you're probably thinking, well, the taskbar's not a problem. You can go up to the taskbar, right click and do taskbar preferences and turn on auto hide. Except in this version of Raspberry Pi OS, we can't do that. There is no option to auto hide the taskbar anywhere. I find it very strange, but there isn't. And you can mess around in config files and simulate it. It does sort of work, but you still end up having the pointer. And so what we're going to do is something a bit different. We're going to close that, and we're going to do something I've never done in Raspberry Pi OS before. And it's very exciting. And what we're going to do is to press Ctrl-Alt F1. And this takes us to the first virtual terminal. And here we can bring up the same command we just executed. It's in the buffer. There we are, and we'll execute the command. Sorry about the size of the font, but I assure you it's there. And now, there we have a clean preview. And I'll just put my fingers into shot to prove to you it is a real shot like that. I can again mess around with the focus like that. And there we are. We now have a clean HDMI output for recording. And we could record this using an HDMI recorder. Over here I'm doing exactly that. Well, I must be because you're watching a video. Here is my Blackmagic Design Video Assist 4K recording the output via HDMI. It has got 2 mini XLR inputs here, so it's also recording from a microphone which is plugged in up there. You can see it bounding around there. So this is exactly the setup I used to record the opening to this video. Video coming in from the Pi via HDMI and my audio via the mini XLR input. And if you're wondering how do we stop this, well, we could press Ctrl-C like that. How do we get back to the desktop? We could do Ctrl-Alt F7. There we are. How would we get back to the virtual terminal? Same way as we first got to it, Ctrl-Alt F1. We could bring back our preview like that. And if you're thinking I sound very excited, I am. I'm very excited indeed to be experimenting with a Raspberry Pi camera. Right, I said I'd say more about the lenses I'm using, so let's do that. But before that, let's say a couple of words also about the Raspberry Pi high quality camera. This is the module. It's quite a small thing. On the back it has got a ribbon cable connected to a Raspberry Pi, and on the base it's got a 3.5mm thread for mounting. And if we take off the cover, this comes without a lens, and you'll see inside here there is the sensor. There is the sensor, and this is a version of the camera which will take a CS mount lens, although it also comes with this adapter for taking a C mount lens. And there's also a version of the high quality camera available which will take an M12 mount lens, so there's various options that you can work with if you choose to get one of these. And talking of getting one, this currently costs about £48 or $50 at the time of making this video. Anyway, let's move on now to the lenses, and this is by far the best quality lens I'm using with the camera. It's one of 2 officially sold to go with it. It's a 16mm telephoto lens. It costs currently £48.90 or $50, and we can adjust on the front the focus, and we can also adjust the iris at the back there. Nice, just nice quality this. It feels better than the other lenses we're using. However, let's now look at those lenses, and first we have this, which is the official wide-angle lens. This is a 6mm lens. Again, we can control the aperture and then the focus at the back. This is a softer lens than the telephoto lens we were just looking at. It's also significantly cheaper. This cost £25.20 or about $34, and it's CS mount, so it doesn't have to be used with the adapter when you use it on the Pi camera. Finally, I've also purchased this lens for the princely sum of £16.99, which is about $22.50. I got it on eBay. There's lots of lenses look very, very similar to this, costing just under $20. And this is 6 to 60mm, so it's a zoom lens. We therefore have 3 control rings, one for wide to telephoto, one for the aperture and one for focus. And we'll just see what this is going to do. I've not put it on the camera yet, but if this works, it'll be fantastic. And this is again C-mount, so it'll need the adapter when we put it onto the Pi camera. So let's see how these perform. And first I've got fitted the 16mm lens, which is by far the sharpest. Let's just go and adjust the focus for you. You can see we've got reasonable control here. It is tricky to focus these lenses, but if you've got a decent sized monitor connected to your Pi, you can do it reasonably well like that. I'm impressed with this lens, but let's now compare it to the 6mm lens, which gives us a more wide angle view, as we can see. That's what we would expect, but it's not as sharp a lens. Nice little lens, but clearly not as sharp as the 16mm. So let's now test our wildcard for 6 to 60mm zoom, which absolutely is not specified to work with the Raspberry Pi high quality camera. It doesn't cover the right sensor area, but as you can see, it does work. It gives us a very nice close shot at the same distance with a shallow depth of field. But if I go into the focus, I can obviously place focus where I want it, and focusing this lens is actually easier than the other two lenses. And when I actually come out, you'll see one of the problems we have though is that once we come out too far, we get black rings at the edge. You can see them there because it's not designed for the same sensor area. So the usable area is to about there, and I'll bring this back into focus if I can find focus. Where is it? Too many rings to adjust with my fingers. I can't see what I'm doing. But anyway, there we are. I'm impressed with this lens. It was a good eBay purchase. Next, I've plugged the HDMI output from the Pi into the HDMI to USB adapter I showed you earlier. I can't remember exactly what it cost, but I'll put the price up on the screen. There it is. And the USB end of the adapter can now be plugged into a PC. This one happens to be running Linux Mint, but the operating system is pretty much irrelevant. It could be running Windows, whatever you choose. And what we're going to do here is to go to the menu, and we're going to run up from sound and video. I think we'll run the Cheese webcam program. We could use OBS Studio for this, but Cheese will do for now as a basic test. We'll do that, and we'll just make this a bit bigger. And the Pi is currently turned off, so I'm going to turn on its power, or more accurately, I'm going to plug in its USB power cable like that. The Pi should now boot, and we will see that on the screen. There we are. In effect, the adapter is turning the Pi into a webcam, so we'll just speed on through its boot process. There we are, and I've got a keyboard and mouse plugged into the Pi, but we could control it remotely, but I've got a keyboard and mouse plugged in, so as you can see, we control it like that. So on the keyboard, I can press our Control Alt F1, and I can bring up in the terminal there the command to run the preview, and it'll come up in a second like that. There we are. And we could now therefore record this using the Cheese program, or we could use just a Pi cam as a webcam. As you can hopefully see, this is a useful thing to be able to do. So I just thought I'd show you that. I'm not going to go through the great detail of that, but I do appreciate not everybody has HDMI recorders lying around as I do, but using an HDMI to USB adapter as here, we can easily record the output from the Pi cam on another computer. And of course, in doing so, we can record audio from any microphone connected to the PC. So far, we've been recording from the Pi on another device. However, we can record video here in Raspberry Pi OS and in several different ways. Indeed, I once built a robot that had remote-controlled recording from a Raspberry Pi camera, and I'll provide a link in the video description. But here, let's just do a quick recording in the terminal, and I've got a command set up to do just that, to record a 20-second H.264 clip. And if you want to know all the syntax for these commands, there's some fantastic documentation on the Raspberry Pi website, and I'll also link this in the video description. Anyway, let's go back to our terminal and execute this command. There we go, we've got a preview. Here is little panda. Hello, I'm a panda. I'm moving around in a test video being recorded. Oh, looks that way, looks this way. Very exciting. What's going on? I don't know. I'm a panda. I wonder how long it's going to go on recording. It's recording for 20 seconds, panda. That's a long time, isn't it? Dooby-doo, dee-be-doo. Oh, I think it's finished. So we can go across to the video folder, which I happen to have open there. There is our test recording. Let's play it. Bring it up like that, and we will full screen. And there's our panda. Oh, look, he's moving around. Isn't it exciting? Oh dear, I think we've got our encoding rate not quite right there, because it's working but not working brilliantly. Although it's exciting, isn't it? Rather interesting effect. But this isn't the way I would choose to record video on a Raspberry Pi these days, because we now have this fantastic open source project called CinePi. And so I think it's now time we turned our attention to that. Greetings! Here I am back again, and I've now reconfigured my Raspberry Pi high quality camera rig into the CinePi setup I covered in a recent video. So what we have here is a totally self-contained unit with a 4-inch touchscreen plugged into a Raspberry Pi 4, an 8GB Raspberry Pi 4, although a 4GB Pi 4 will also work, and it records video to an SSD. We've got an M.2 SSD caddy down here plugged in via USB to the Pi, and everything is powered by a USB power bank. This is a 10,000 mAh USB power bank, which provides at least 6 hours battery life for the CinePi. So you can take this rig out to shoot with it and just leave it on. You don't have to worry about running out of battery power. CinePi records sequences of 12-bit raw DNG frames, so the final footage from the CinePi needs to be edited and graded in an application that can handle these, such as the free version of DaVinci Resolve, as I demonstrated in my previous CinePi video. So let's set up for a typical explaining computers shot, and here we are with the CinePi all set up to record a single board computer, a Rock 3C, using the official 16mm lens. So let's take a look at the shot it's recording. There we go. And if you're wondering how this compares to a shot taken on the Panasonic HCX2 that I normally use, here is a comparison shot. Although right now I've got no idea how this does compare, as I've yet to see the CinePi output that you're currently looking at. This said, shooting with CinePi is in some ways easier than our earlier setup, due to the extensive on-screen manual controls. However, even though the touchscreen is excellent, focusing is more challenging given the size of the screen compared to the HDI monitors I was previously using. It's also worth noting that the version of CinePi I've constructed does not record audio, and so audio has to be captured separately, either using a standalone audio recorder or via another camera if CinePi is being used, as here, in a multi-camera shoot. Either way, a visual sync mark is needed, and here I'm going to make this by clapping together these two HDMI couplers. Let's bring these into shot like that and go there we are, that's hopefully left a good visual sync mark. And of course normally you'd do that at the start of the shot, you wouldn't see it in frame like that, but I thought I'd show you the whole process. Anyway, let's now turn the SBC over. Let's do something like we normally do in an explaining computers video. There we are, we can see underneath. There we are, and we'll turn it back again, something like that. There we are, and I can't get it right on the screen. I can't see the monitor properly shooting with CinePi, but I'm sure I could get used to that. And I think we'll now also have a shot of the SoC, a close-up, as I often also do in the video. And then I think we'll have a shot of the main long edge with some of the connectors on the Rock 3C, including the always welcome full-size HDMI socket. Now, because CinePi is portable, earlier I ventured outside to introduce it to my garden, where some tulips are in bloom, as we can see. And whilst the footage is as previously a little soft, after a bit of post-processing it does look pretty good with some great bokeh. Also in bloom in the garden right now are some rather magnificent buttercups, including this charming specimen, And there's also extra yellow added by loads of dandelions, including these two, which I assure you are very happy twins, although these are not flowers that all gardeners would welcome. Close by, we also discover some bluebells, inside which a small group of elves and fairies are probably having a nice party, and which, as with most of the close-ups here, come out pretty well with the 6-60mm eBay lens. Finally, these bedraggled daffodils are most certainly past their prime, but they're still standing proud in their old age, and I can assure you they were very pleased indeed to be asked to star in this video. So there we are. We've proved that it is possible to shoot YouTube video on a Raspberry Pi camera, although we've also proved, as we saw in the last part of the video, that some subjects are more challenging to shoot than others. Although this isn't a surprise to me, I've known for 17 years that it would be easier for me photographically if this channel were called Explaining Flowers rather than Explaining Computers. It's also important to note that the quality of the images we've seen from the Raspberry Pi camera in this video have largely been a function of the lenses we've been using rather than the quality of the sensor in the Pi camera itself. We've been using relatively cheap lenses and very cheap lenses in the case of this particular lens. And I did think about getting an adapter so I could fit a lens like this onto the Raspberry Pi high quality camera, but that would have turned the high quality camera into quite an expensive camera, which would have kind of negated the whole point of what I was trying to do in this video. But I might still do that in the future. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe. And I hope to talk to you again very soon.